Thank you very much. Good afternoon, ladies and gentlemen. I will present the results about stress analysis in a spherical pressure vessel with 2 growing corrosion pits. Short start, pressure vessels are widely used for holding gases and liquids. For gas and oil industry, they are often made from metals. So the corrosion is the important issue for this topic. And one of the most dangerous forms of corrosion is the local corrosion, for example, pitting corrosion. Once appeared, surface defects acts as stress concentrators and cause high local stresses and result in acceleration of the destruction of whole structure. And it is really important to assess the strength and reliability of the structure that is under corrosion attack. Pitting corrosion is really hard to predict and to investigate because it's a highly multi-parametrical problem. So despite many authors have investigated the effect of pits on different structures, still a lot of questions has no answers in this field. Because it's really highly multi-parametric. So we made an attempt to study the growth of 2 corrosion pittings on the outer surface of the spherical spherical pressure vessel, and to analyze the effect of parameters, especially geometrical parameters, and we vary few parameters like initial depths of pittings, sizes of the vessels, and distance between pits. So we consider cylindrical corrosion pits with a hemispherical bottom, and we assume that the pittings grow with time only in the depths. So the cylindrical part of pittings became longer, and the whole geometry still is the same. There are a lot of models of corrosion, how corrosion is accelerates and what is going on with pittings, how do they exactly grow. We consider the mechanochemical corrosion rule, which means that corrosion rates depend on the stress in the at the surface of the shell. The stress here is the stress at the bottom point of the pitting. So the higher the stress at the point A, the faster is the corrosion process for this pit. At each step, we can calculate the rate of the corrosion for the pit like this, and to recalculate the length of the depth of the pitting. We considered few initial geometries for our problem, and here there are sizes and distances between pits and initial depths. We use ANSYS space claim for using geometry and ANSYS workbench to calculate stresses. the whole process was like this. We choose the initial geometry and build it. Then we go to MSys Workbench and mesh the model and set the boundary conditions and solve the problem and find the stresses at the bottom of the pits. Then we calculate corrosion rate for each pit and calculate the depth of both pits for the next step. Then we build another geometry where the pits are deeper and go with this circle again and again and again, so that we make the model of growing pittings on the surface of the shell. Firstly, we considered the vessel of these sizes, and we tried to find is there an effect of distance between pits on their interaction and the growth of it. There are six lines on this graph that I bet you can see them, but believe me, they are there. So one of our important expectations was that we will see actually the sixth curve on this graph, but it didn't happen. So it means that the distance between pits doesn't really affect our corrosion process. And then we decided to consider different distances like this. So, and it didn't work so well for us. So we considered another parameters. We changed the radius of the shell. Because when we consider two pits, imagine that one is starting here and another is starting here, and they both grow into the shell. So when they are deep enough, they will probably interact more if the size of the shell is less. So we reduced the size of the shell and checked what is going on. It helped a little, and it enhanced their interaction between pits. So they start to grow a little bit faster, but not so fast so we could see it like in a graph. But the distribution of the stress field changed a little at the initial geometry, because when we have shallow pits, we have the maximum stresses on the bottom of the pits. But when our pits are growing and became really, really deep, the maximum principal stress has its maximum not in the not at the bottom of the pits, but at the ligament between them. And this little bit changed when we changed the size of the vessel. Here, we for the big vessel, we found that the stress has its maximum on the ligament earlier than for the vessel with reduced sizes. And then the reduced sizes once again, and it enhanced the interaction between pits a little bit more, but still not really big influence we can see of the interaction of those pits to make it really grow faster than single pit on the surface of the same shell. So we had our expectations between about that the distance between pits will have big effect on the stress state of the shell, and another one expectation that the sizes of the shell will have a big effect on the corrosion rate and on the stress state of the vessel too. But it appeared that for our considered parameters, we didn't see it. Though it raised new questions for our further research, and I hope we're going to have it. So thank you very much for your attention.